Hello everyone, this is our first video example related to our lecture where we talked about the last two process variables of pressure and temperature. In this example, we are going to talk about do an example on using head of fluid and how do we convert head of fluid to pascals and vice versa. This is example 3.4-2 from the textbook on page 59. I have modified it slightly to add more parts to it, and hopefully that will help you understand this idea of head of fluid a little more. So in this question, it's asking simply, what is the pressure 30 meters below the surface of the lake? And we want it in different units. We want it in meters of water, kilopascals, and meters of carbon tetrachloride. We are given that the atmospheric pressure is 33.9 feet of water. We're given the density of water as 1,000 kilograms per meter cubed, and we're given the gravitational acceleration. So simply, what are we asking? What is asked of us in this question? Let's say this is the riverbed or the lake bed, and we have our lake right here, and this is 30 meters deep. There is some atmospheric pressure above that, and we are told that this is 33.9 feet of water. We want to know what is the pressure exerted by at the bottom right here. So think about yourself diving down 30 meters below to the bottom of this lake. What is the pressure that you feel down there? So let's do this just simply in head of fluid, because in part A is asking in meters of water, which is a head of fluid or head of water. I'm going to just simply convert my atmospheric pressure. Right now we are given as 33.9 feet of water. I'm going to convert it to meters of water. This is not a pressure conversion, this is a length conversion. We are just converting what is 33.9 feet in meters. So I'm using a length conversion here of 1 meters is 3.28 feet. 33.9 feet of water is equivalent to 10.3 meters of water. So why am I doing that? Because if I know that atmospheric pressure is equivalent to 10.3 meters of water, and I'm adding another lake, 30 meters of lake water, so this is a simple summation of heights or lengths in this case. The pressure that you'll feel in head of fluid or head of water is just 10.3, which is atmospheric, plus another 30 meters of water. So the pressure you're going to feel at the bottom of that is 40.3 meters of water. So hopefully you see, in terms of head of fluid, it can be a very powerful and easy tool to figure out pressures if you're doing everything in just head of fluid. Because in that case, you're just simply summing up lengths or heights in this case. In part B, it's asked you for the pressure in kilopascals. So we're going to convert from 40.3 meters of water to pascals. That would be converting between a head of fluid and what we're used to in terms of pressure. The conversion between that, like we've talked about, is rho GH. So P is equals to rho G times the head of fluid. Where does the length and the type of fluid come in? In this case, we are going to use the density of water because we are doing water right here. And the pH, the height, the 40.3 would be in this pH right here. So now we just have to put in the numbers, do everything in SI units. We know the density of water, 1,000 kilograms per meter cubed. We're given the gravitational acceleration, and we have the height of the fluid, or the height of water. We put it into our calculators. You'll notice that the units are going to come out as kilograms per meter second squared. We are doing everything in SI, so I know for sure this is some SI unit of pressure, which happens to be the base units for pascals. So if I want 8 kilopascals, I divide it by 1,000, and I have 395 kilopascals. Alternatively, you can actually just, there is actually conversions from head of fluid for water in atmospheric pressure in the front of the book. So you could just use the conversion factor from the front of the textbook. We have 40.3 meters of water. The front of the textbook gives you atmospheric pressures in different units, which is 101.325 kilopascals or 10.323 meters of water. So you could use that as a conversion factor, and from there you can still get the same answer of 395 kilopascals. All right, the last thing we want to do is to convert into another set of head of fluid, but now instead of head of water, we want head of carbon tetrachloride. So I'm going to show you two ways to do it. One way is using the 395 kilopascals, using that same equation in B, but working backwards. And another way, we can actually use 40.3 meters of water, so doing a head of fluid conversion from one type of head of fluid to another fluid. So in the first way, we're just going to use that same equation, P is equals to rho GH. But now in this case, we're looking at carbon tetrachloride. So the density we're looking at is the density of carbon tetrachloride. And what we're trying to solve for is what is this pH right here that will give us our pressure in head of carbon tetrachloride. In terms of the density, we can look that up in table B1. It will give us the specific gravity, multiply that by our reference density, which is the density of water, and we get 1595 kilograms per meter cubed. We can put it all into our equation, doing everything in SI units, so converting to pascals, and now we know that the answer that's going to come out is going to be in SI units, which is meters, and that will give us 25.3 meters of carbon tetrachloride. That's the first way of doing it. The second way of doing it is using our 40.3 meters of water. So we're doing from one unit of head of fluid to another head of a second type of fluid. This is the definition of head of fluid in water, and this is in carbon tetrachloride. The only difference is the densities, and obviously you're going to have different heights to give you that same pressure. You can see that in this case, by doing it this way, the G cancels out, so you don't have to worry about the G. We want to solve for the head of fluid of tetrachloride. So if I rearrange this equation, you can see that it's a ratio of the densities of the two fluids we're talking about. This is nice because we don't really need the actual values as long as they have the same units. So we could potentially even use just the specific gravities of those two values. But it turns out we already have the density, so we'll just use the densities 1000 over 1595 multiplied by the head of water, and you'll end up with the same answer of 25.3 meters of carbon tetrachloride. So that's all we have for this example. Hopefully it's helpful in terms of understanding the use of head of fluid. How do you convert between head of fluid and pascals? In our next video example, we'll be doing an example of manometers. So go ahead and look that up. Work hard, be smart. I will see you in the next lecture.